Okay, now there is what is called as a pedal equation. This is related to what is called as our polar curves. Already we have seen there are several types of polar curves. Polar curves. They can represent the polar curves in a different variety of format, but ultimately we are trying to relate the r and theta. R is the radial distance from origin for any point on a curve, and theta is the angle made by the radial line or radius vector with respect to the x-axis of the Cartesian coordinate system. Okay, now if you want to relate what is called as the value of the r and theta in a different format, right? That is called as a pedal equation. Let's try to write now. Okay, so this is basically we are trying to represent in the following notation. Okay, and now we know that there is what is called as the length of a perpendicular, right? This is denoted by a small letter p, right? This is length of the perpendicular from the pole, okay, from the pole to the tangent, right? So we know that what is a tangent. We already have found the relationship how to find this tangent, right, in the previous classes of the polar curves. Okay, so with respect to that, now we know that there is what is called as a r, right? So length of the perpendicular p from the pole to the tangent, right, is represented in the form of an equation, right? So we know that this is the format. P is equal to r into sine theta. This is one format. Okay, there are many other formats in which we can write the pedal equations. It could be one of them. Okay, this is the first format. The second format is 1 divided by p square is equal to 1 divided by r square into this is cosecant square theta, right? That's the second format. Or you can also write in the third format 1 divided by p square is equal to 1 divided by r square into this is 1 plus cot square. Okay, so this should be phi. Sorry, my mistake. So I wrote as a theta earlier. Let me correct. So this has to be the phi. So we know what phi stands for, right? It's that angle phi which we are supposed to use here. Any of these three formats you can use to get the pedal form or pedal equation of any given curve. All right, so let's start with the problems. The problem number one is, in each of the cases it is expected that you try to find out the pedal equation, right? So equation of the first problem is 2a divided by r is equal to 1 plus cos theta. All right, so normal procedure, as always, you try to take a log here, log on both sides. This is log 2a, and you have a denominator, so this is minus log r is equal to, this is log of 1 plus cos theta. Okay, then as usual try to differentiate this. So log 2a becomes 0 minus log r is 1 by r into this is dr by d theta is equal to, so log of 1 plus cos theta differentiation is 1 divided by 1 plus cos theta, multiply that, cos theta differentiation is minus of sine theta. Okay, so this is on the left hand side. I can see that this is minus 1 by r dr by d theta, which is nothing but, I can say this is minus, anyway I'll cancel the minus and minus on both sides will cancel. So 1 by r dr by d theta is cot, this is cot phi. So cot phi is equal to, on the right hand side I can see that this is sine theta by 1 plus cos theta. Let me make a substitution. So previously we have seen that if you have a sine theta, you can try to write the sine theta using the half angle formula, that is 2 times sine theta by 2 into, this is cos theta by 2 whole divided by 1 plus cos theta can be written as 2 times half angle formula cos square theta by 2. So 2 gets cancelled, one of the cos theta cancels with this, so you have sine theta by cos theta, that is tan of theta by 2. Now I need to understand that cot and tan, right? Cot of an angle and tan of another angle becomes equal, and they are positive in the first quadrant. So this means I have to write in the following notation. This is cot phi is equal to, I want to change the right hand side tan function into a cot function, and they have the same sign indicating that it should be in the first quadrant. So first quadrant means it is 90 minus theta. So this has to be cot 90, which is pi by 2, minus that angle. So this is theta by 2. Both sides I have cot, I can cancel cot. So phi is equal to pi by 2 minus theta by 2. This is what is my first conclusion about the given data. Right? So you see that our requirement is that I have to write, right, the pedal equation now. Pedal equation, the most simplified format will be P is equal to R into sine phi. R sine phi is our function. Okay, now if you want to write P is equal to R sine phi, then let me write it in the value, because phi value is pi by 2 minus theta by 2. So I can replace this. This implies the P value is equal to R sine of phi. From the above equation I can write pi by 2 minus theta by 2. Right? Sine of 90 minus theta. 90 minus theta means it sine becomes cos. Alright, so this means the P will be equal to R into, this is cos theta by 2. Alright, now so this should be the fine answer. This answer should be fine, but now our ultimate goal is that I want to eliminate what is called as the theta from this. You should have normally only P and R. So let's try to eliminate this theta now. Right, let's hold on to this. Okay, I'll write, I'll denote the given equation by one of the format. Let's say this is 1. Okay, and let me say this answer which I got now is 2. But so in order to eliminate the theta, what I try to do here, right, let us try to write the equation 1, right? So equation 1 I'll write once again just for our reference. I know that from equation 1, this is 2a divided by r is equal to 1 plus cos theta, right? But what is 1 plus cos theta? I can actually replace 1 plus cos theta as 2 times, this is cos square of theta by 2. Alright, so if you want to write this, I can replace this. 2 gets cancelled. This means a by r is equal to cos square of theta by 2. Okay, but what is cos theta by 2? I can take a square root on both sides, correct? A by r, right? So, but I know something, right? From equation number 1, equation number 2, let's hold on to this equation 3. But from 2, I know that what is a cos theta by 2? Cos theta by 2 is P by R, right? I can see that cos square theta by 2 I have, which is nothing but square of this, correct? I can put this. So this is 4. So 4 in 3 gives, you see, this is a by r, which is equal to cos square theta by 2, but cos theta by 2 is P by r. So this is p by r the whole square, which is p square by r square. So one of the r will cancel, right? So now you see I have p square on one side, a into r, right? The p is what I need. P is equal to something I need. So I can write this as p is equal to root of ar, or p square equal to ar. Now you see that you eliminated the theta from the equation. That's why this is called as the pedal equation. So I should always try to relate the length of perpendicular p and the radius vector r in such a way that there should not be the theta present in your equation. Theta should not be there because you are not relating theta over there. Should relate p and r without theta. Okay, so that's why it is called as a pedal equation. All right, now let's then proceed to the next problem. Next one is like this. This is r into 1 minus cos theta is equal to 2a. So by default, I have to take a log now. So this is log r plus log of 1 minus. Okay, so this is log of 1 minus cos theta is equal to, this is log of 2a. Let us try to differentiate the given function. So log r becomes 1 by r dr by d theta plus, this is 1 by 1 minus cos theta into differentiation of minus cos theta is sin theta equals to log 2a differentiation becomes equal to 0. So this implies I have 1 by r dr by d theta is equal to minus of sin theta by 1 minus cos theta. Alright, so let us do the substitution. On the left hand side I have this equal to cot phi. So what is cot phi? Right side I have minus of sin theta is 2 times sine of theta by 2 into cos theta by 2 whole divided by, this is 2 into sine square theta by 2. 1 minus cos theta is 2 sine square theta by 2. I can see that the sine and sine cancels. 2 will cancel with the 2. So I am left with cot phi is equal to minus of cot theta by 2. So cot will definitely get cancelled here. This implies the phi becomes equal to theta by 2. This is the first relationship that we get. Now let's start with the pedal equation first. So the general form of the pedal equation, we always start with one of the standard format of the pedal equation. So in this case, let's start with the easiest one, that is p is equal to r into, this is sine phi. So that means p should be equal to r into, so you can see that the sine phi becomes sine of minus of theta by 2. I know that sine of minus theta is minus sine theta. I can write this as minus r sine theta by 2. Let's hold on to this equation. Okay, this is equation number 2. From the given equation, I am writing this now. So original equation given, which is r into 1 minus cos theta should be equal to 2a. Okay, now let us try to substitute what happens with the 1 minus cos theta. So that is r into, what is 1 minus cos theta? We know that it is 2 sine square of theta by 2 should be equal to 2a. Right? I will cancel the 2 with the 2. So I have r into sine square theta by 2 is equal to a. Right? Now let's try to substitute now. So this is what is the sine? So let's try to write an equation for sine square theta. This is, I know that r into sine square theta by 2 is equal to a. I'll write this once again. So r into sine square theta by 2 is equal to a. Let me call this is 3. But from equation number 2 I can write what is sine square theta. What is sine square theta? From 2 take r to the other side, this becomes p square by r square. So call this 4. This is, I wrote this from equation 2. Okay, so now this implies, substitute r into, there is a sine square theta. Sine square theta from equation 2, equation number 4 is p square by r square is equal to a. So cancel one of them. So this implies the p square is equal to a into r is the required pedal equation. So always, right, this will be the standard procedure irrespective of whatever problem given. You can solve that using this method. Okay, right, let's go to another question. This is equation is r square is equal to a square into secant 2 theta. When you take log, this becomes n log r is equal to, this is n log a plus log of cos n theta, isn't it? So differentiation will give you n into 1 by r dr by d theta is equal to, this term is 0. Then I have plus log of, this is 1 by cos n theta into differentiation of cos n theta is minus n into sine of n theta. So you can see that this n and this n should cancel, and then I am left with cot phi is equal to, this is minus sine by cos, which is tan n theta. So we can write now this is equal to, since the term is in the second quadrant, cot of pi by 2 plus n theta. So cot get cancelled, the angle phi becomes equal to pi by 2 plus n theta. This is the angle phi. So the pedal equation, so what is the pedal equation? General format, P is equal to, this is R into sine phi. Right, let us substitute. This implies the P value is equal to R into sine of, what is the phi value? It's pi by 2 plus n theta. Okay, now when this is sine of 90 plus theta, it goes to the second quadrant. Okay, in the second quadrant sine is positive, so sine of 90 plus theta becomes simply cos theta and it is positive. So this is equal to, P is equal to R cos of n theta. Okay, let's hold on to this now. This is, let's call equation 1. But let's look at what is given. In the given equation, they have mentioned that r to the n is equal to, this is a to the n into cos n theta. So from this I can write cos n theta is equal to, if you want to retain this, this becomes r to the n divided by, this is a to the n. So call this as, right, equation number 2. Now put 2 in 1. What happens? Equation 1 is P is equal to R into, instead of cos n theta I'll substitute equation 2, that is R to the n by a to the n. Okay, take, this means take a n to the other side, so P into a to the n is equal to R to the, already there is a power 1. R to the 1 plus R to the n is R to the n plus 1. You see that we have eliminated the theta from our equation. So this is the required pedal equation. Okay, please go through this answer once and let me know if you have any doubt. Next question. R is equal to 2 into 1 plus cos theta. Sure. What is the phi? Minus sin theta by 1 plus cos theta. That is cot phi, correct? Yeah, we get cot phi is equal to minus of sin theta by 1 plus cos theta. So what we do here, we try to simplify this further by substituting half angle formula, right? So this is minus 2 times sin theta by 2 into cos theta by 2 whole divided by 1 plus cos theta is 2 into cos square of theta by 2, right? You can see that this cos will cancel with one of the cos, 2 and 2 will cancel, so we have cot phi is equal to minus tan theta by 2. So cot is negative means this has to be in the second quadrant, correct? So cot phi second quadrant means this is nothing but I can really remove the tan and I can write cot, but it is in the third quadrant. So this is cot of pi by 2 plus theta by 2. Okay, so this means phi is equal to pi by 2 plus theta by 2. Once this phi is calculated, our next intention is to put this into the pedal equation, correct? So let's start with the pedal equation. So that is given by P is equal to R sine phi. So P is equal to R sine of phi is nothing but pi by 2 plus theta by 2. That is, once you have sine of 90 plus theta, that is cos theta. So this is saying that P is equal to R into cos theta by 2. Correct? R cos theta by 2. Let's hold on to this now. Let's look at what is given. So in the question, they have mentioned that the R is equal to 2 into 1 plus cos theta. Okay, so I'm going to make a modification here. 1 plus cos theta is 2 cos square theta by 2. Okay, so this means I can write R is equal to 4 cos square theta by 2. Let's hold this as equation number 2 and I'll try to modify first equation. Equation 1 says that cos theta is equal to P by R. This is what equation 3. Now what you can do, you can put this equation number 3 in equation number 2. Correct? Because I can see a cos square where every cos I can replace as P by R. Right. So this is equation 3 in equation number 2. Okay, when I put this over there, I'm going to get r is equal to 4 into cos square, which is p square by r square. Take r to the other side, so r cube is equal to 4 times p square. You can see that we have eliminated the theta from the equation and we are relating p and r. There can be constant like 4a or whatever coming up, but once this is done, you can say that that is your final answer of pedal equation.